Kia ora Year 12. This is the first video I'm going to make looking at some of the harder questions from this year's school exams. I'm going to start with question 1F from the algebra paper. So here's the question. If the roots of the quadratic equation, given in general expanded form, differ by 4, show that b squared equals 4a times 4a plus c. So the first thing to note is that it's a show that question. You're given the answer, so that means you've got to be very careful not to miss any steps on the way through. We don't know much about this equation, so we're going to probably start with using the quadratic formula. So let's think about what that tells us. Well, don't know what happened there. There we go. Okay, so x is equal to, in general, negative b plus or minus the square root of the discriminant divided by 2a. So we know that there are two solutions to this quadratic, and they differ by 4. So we can call the roots alpha and beta. And we know that alpha minus beta equals 4. So you might want to go and try and do something with the sum and product of the roots, but I didn't do that. I did it like this. I said, well, we know the big root is going to be the one with the positive sign. So we're going to have negative b plus this must equal the smaller one with 4 added to it. Okay, so we're going to start with the statement here. And all we have to do for the rest of the question is manipulate this step by step until we end up with our end result. So I'm going to do this really slowly. We're going to go negative b over 2a plus the discriminant over 2a is equal to negative b over 2a. We're already thinking that that's good because we can see some simplifying coming, minus the discriminant over 2a plus 4. All right, so the next thing I can do is that I've got this term and this term are exactly the same. So we can subtract those from both sides. And we've got b squared minus 4ac over 2a is equal to negative the discriminant Right, now I've got two identical terms here, so I'm going to add this one to both sides, and that'll give me b squared minus 4ac. Sorry about the background noise, just a sec. Okay, so we've got b squared, the root of the discriminant over 2a, plus the same thing, is equal to 4. Now, that gives me two lots of those. So 2 times the root of the discriminant over 2a equals 4. And I should be starting to feel happy because I can see some things simplifying already. So b squared minus 4ac divided by a is 4. You've probably stopped watching already because you've probably figured out how to finish it off. If I now square both sides, we get b squared minus 4ac is equal to 16a squared. And remember, right back at the start of the question, where am I trying to go? So I'm going to scroll back up and show you again. We're looking to end up with b squared equals blah, blah. And we're just about there. So now we have b squared is equal to 16a squared plus 4ac, and we can factorize out 4a, and we get 4a times 4a plus c. All right, so that's an example of a question that looks very difficult when you first read it, but then you think about the things that you know. And at level 2, the quadratic formula is often going to come up in harder problems like this. So it's a matter of very slowly and carefully working your way through. All right, that's all for now. I'll try and do some more later on this week. Let me know if there are any particular questions you'd like me to YouTube. Thanks for watching.